When estimating electrical work, begin with general lighting. A common starting point is to allocate approximately 1.5 watts per square foot. For a 3,000 square foot home, this equates to 4,500 watts for general lighting. For the kitchen, consider the dedicated circuits for appliances. A 50 amp range and a 30 amp air conditioner represent significant loads. To calculate the wattage, add the amperage of the range and air conditioner, in this case 50 amps plus 30 amps, totaling 80 amps. Then multiply this total amperage by the voltage, which is typically 240 volts, resulting in 19,200 watts for the kitchen. The garage, with 3 total outlets and a light, can be estimated at 500 watts. The basement's general lighting can be estimated at 2,000 watts. Outlets and ground fault circuit interrupters, GFCIs, are essential in any modern home. Assuming 125 outlets or GFCIs, you can estimate a cost per point. At $30 per point, this would be $3,750. Exterior lighting and outlets can be estimated at 500 watts. Adding all these estimated loads, including general lighting, kitchen, garage, basement, outlets, and exterior lighting, the total estimated load is 27,650 watts. The service panel is rated at 200 amps at 240 volts. Estimating cable length is crucial for accurate bidding. There is no exact formula to calculate cable length based on square footage and openings, but there are rules of thumb. Firstly, for general lighting, estimate approximately 50 feet of cable per room. Secondly, for outlets and GFCIs, estimate approximately 25 feet of cable per outlet or GFCI. Thirdly, for kitchens and bathrooms, factor in additional cable for appliances and fixtures. Based on these guidelines, we can estimate the total cable length. For 4 bedrooms, at 50 feet per room, this is 200 feet. For 125 outlets and GFCIs, at 25 feet per outlet, this is 3,125 feet. An estimated 500 feet is allocated for the kitchen and bathrooms. Summing these estimates, the total estimated cable length is approximately 4,125 feet. Remember that these estimates are only approximations. Several factors can influence the actual cable length required. These factors include the specific design of the house, the placement of outlets and fixtures, and the routing of cables. For instance, if the house has long runs of cable between rooms or floors, the cable length will be greater. If the house has many corners or obstacles, this can also increase the cable length. Furthermore, local electrical codes may dictate specific requirements for cable routing and installation, which can also affect the overall length needed. To create a more accurate bid, consider the following steps. 1. Review the blueprints or plans for the house. This will give you a better understanding of the layout of the house, the placement of outlets and fixtures, and the routing of cables. 2. Perform a walkthrough of the house. This will allow you to identify any potential challenges or obstacles that may affect the cable length. 3. Consult with a qualified electrician. An experienced electrician can provide valuable insights and guidance on estimating cable length and other electrical work. 4. Use a cable length calculator. Several online cable length calculators can help you estimate the cable length based on various factors such as the size of the house, the number of outlets and fixtures, and the distance between them. Cable comes in various sizes and types, each suited for specific applications. The appropriate cable size depends on the amperage of the circuit it will serve. For example, a 15 amp circuit typically requires 14 American wire gauge, or AUG, wire, while a 20 amp circuit typically requires 12 AWG wire. Larger appliances, such as ranges and air conditioners, require even larger wire sizes. The cable type also depends on the application. Non-metallic NM cable, also known as Romex, is commonly used for residential wiring. Underground feeder off cable is used for underground wiring. Armored cable AC, also known as BX, is used in situations where the cable needs to be protected from physical damage. When installing cable, it is essential to follow all applicable electrical codes and safety guidelines. Firstly, always turn off the power to the circuit before working on it. Secondly, use the correct tools and materials for the job. Thirdly, properly secure the cable to prevent it from being damaged. Fourthly, ensure that all connections are tight and secure. Grounding is an essential safety measure in electrical systems. Grounding provides a path for fault current to flow back to the source, tripping the circuit breaker and preventing electrical shock. All outlets and fixtures must be properly grounded. The grounding conductor is typically a green or bare copper wire. It is connected to the metal enclosure of the outlet or fixture and to the grounding bus bar in the service panel. Ground fault circuit interrupters, or GFCIs, are another important safety device. GFCIs are designed to detect ground faults, which occur when current leaks from a circuit to ground. GFCIs quickly interrupt the circuit, preventing electrical shock. GFCIs are required in areas where there is a risk of water exposure, such as bathrooms, kitchens, and outdoor areas. The service panel is the main distribution point for electricity in a home. It contains the circuit breakers that protect the individual circuits. The size of the service panel depends on the total electrical load of the house. A 200 amp service panel is common in modern homes. The service panel must be properly grounded and installed according to electrical codes. The electrical codes are a set of rules and regulations that govern the installation and maintenance of electrical systems. The National Electrical Code, or NEC, is the most widely adopted electrical code in the United States. Electrical codes are designed to protect people and property from electrical hazards. It is essential to follow all applicable electrical codes when working on electrical systems. Hiring a qualified electrician is crucial for ensuring that electrical work is done safely and correctly. A qualified electrician has the training, experience, and knowledge to perform electrical work according to electrical codes. They can also identify and correct potential electrical hazards. Attempting to do electrical work without proper training can be dangerous and may result in serious injury or property damage. Several resources are available to help you learn more about electrical estimating and wiring. These resources include online courses, books, and trade organizations. Online courses can provide you with a comprehensive overview of electrical estimating and wiring. Books can provide you with detailed information on specific topics. Trade organizations can provide you with access to training, networking, and other resources. Remember, these estimates are only approximations and may vary depending on the specific design of the house. It is always recommended to consult with a qualified electrician for an accurate bid.